Some octopuses can leave the ocean completely, crawl across wet rocks in the open air, and survive outside water for up to 30 minutes at a time. That is long enough to walk the length of a swimming pool, rest for a while, and then slide back into the sea like nothing happened. For an animal that breathes underwater, this should not be possible at all. An octopus has no lungs. It has no nose. Everything about its body seems built only for water. So how can it leave the ocean, sit in open air, and still be alive 30 minutes later? Most people would guess the octopus must be holding its breath, the way a person does before jumping underwater, except backward. Maybe it just stores up enough air inside its body before it climbs out, then uses that air slowly, like a tiny tank of oxygen. But that guess is wrong. Octopuses do not store air anywhere inside their bodies. They have no air tank, no pocket of gas, nothing like a lung at all. If holding a breath were the answer, the octopus would run out of air in seconds, not minutes. So the real answer is not about stored air. It is about something happening on the outside of its body the entire time. Here is the real mechanism, and it starts with the octopus's skin. An octopus's skin is thin, soft, and full of tiny blood vessels sitting very close to the surface. As long as that skin stays wet, oxygen from the air around it can pass directly through the skin and into the blood underneath. This is very different from how most animals breathe. The octopus is not pulling air into one central spot like a lung. Its entire outer body works a little bit like a lung, pulling in oxygen everywhere at once as long as the surface stays moist. This kind of breathing through the skin is actually not new for the octopus. Even underwater, some oxygen already passes in through the skin, working alongside the gills the whole time. So when the octopus climbs out onto land, it is not switching to some brand new system it has never used before. It is simply relying much more heavily on a system that was already there, quietly helping out in the background, even while the octopus was swimming normally in the sea. This explains why timing matters so much. As long as the octopus stays wet, damp rocks, sea spray, or a light coating of water on its skin, this kind of breathing keeps working. But if the skin fully dries out, oxygen can no longer pass through it properly, and the octopus is in serious trouble. This is the real reason octopuses cannot stay on land for long. It has nothing to do with running out of stored air. It is about staying wet enough for the skin itself to keep working as a breathing surface. There is a second part of the story that makes this even more impressive. Octopus blood is not red like human blood, it is pale blue, because it uses a different substance to carry oxygen through the body. This blue substance works especially well in cold water and in places where oxygen is harder to find, which is common in tide pools and shallow rocky areas near the shore. So even while the skin is working overtime to pull in oxygen from the air, the blood underneath is already built to make the most of every bit it can grab. The octopus also has an unusual heart setup that helps here. Instead of one heart, it has three. Two smaller hearts push blood through the gills, and one larger heart sends blood out to the rest of the body. On land, the gills are less useful since there is no water flowing through them. But the skin is now doing much of that oxygen collecting job instead, so the heart system can still move enough oxygen around the body to keep the octopus moving and alert, at least for a while. Getting oxygen is only half the challenge though. The octopus still needs to physically move across dry land, which is very different from swimming. Underwater, an octopus can push water out behind itself to jet forward quickly. On land, that trick does not work at all. So instead, the octopus uses its arms almost like a group of separate legs, each one gripping onto rocks with strong, sticky suckers, then pulling the soft body forward one stretch at a time. It looks slow and clumsy compared to swimming, but it works well enough to cross short stretches of exposed rock. Each arm can move mostly on its own, almost like it has its own small brain helping it decide where to grip next. In fact, a large part of an octopus's nervous system sits out in the arms themselves, not just in the head. This means the octopus does not have to carefully plan every single grip and pull with its main brain. The arms can react to the rocky ground on their own, finding a good grip almost automatically, which makes crossing uneven, bumpy rock much easier than it would be for an animal with stiffer, more rigid legs. Why would an octopus even bother leaving the safety of the ocean in the first place? In tide pool areas, water levels can change fast as the tide goes in and out. Sometimes the fastest, safest way to reach a better pool full of food or to escape from a hungry fish trapped in the same shrinking puddle is to simply climb out and walk across the rocks to a new pool nearby. It is a short, risky trip, but often a smart one, since staying in a shrinking puddle can be more dangerous than the walk itself. This kind of short land crossing seems to happen more at night or in cooler, cloudy weather when the sun is not beating down and drying everything out so quickly. Cooler air holds onto moisture longer, which gives the octopus more time before its skin becomes too dry to keep breathing properly. Heat is really the octopus's biggest enemy during a trip like this, even more than the distance it has to travel, since a hot, dry surface can end the journey far sooner than tired arms ever would. Zooming out, this behavior shows something important about how flexible life can be, even for an animal that seems built entirely for one single environment. The octopus did not grow lungs, and it did not stop needing water to survive. Instead, it simply found a clever, temporary workaround using the skin it already had in a completely new way. It did not need to become a land animal. It only needed enough time to make one clever crossing. So somewhere along a rocky shoreline, right as the tide begins pulling back, a soft, boneless creature slips quietly out of a shrinking puddle of water. It pulls itself across wet stone, arm over arm, moving with strange, careful patience until it reaches a deeper pool just a few steps away. Then, without any hurry at all, it disappears back beneath the surface as if it had never left the sea in the first place.